Dear student, today we discuss the miscellaneous trigonometrical integral where the I integral is given that root of sine x minus a and divided by sine x plus a. Okay, then I start this question and at first I am on my stock. I am teaching maths to board classes and UGC classes and C foundation also. So we start this question. At first, we multiply the numerator and this denominator by sine x minus a, so we can get identity in denominator. So I write here multiply numerator and denominator by sine of x minus a, and for this integral is equal to sine of x minus a multiply sine x minus a and divide by sine x plus a multiply by sine x minus a dx. Yes, in this operation that the multiplying the numerator and denominator by sine x minus a, then there is identity sine x plus a and sine x minus a is equal to sine square x minus sine square a, and this term without of sine. So here is sine x minus a dx and divide by root of sine square x minus sine square a. Okay, now again expand this by the trigonometrical formula sine x minus a is sine a minus b, then get the I integral is equal to, there is sine x and cos a minus cos x and sine a, and as the denominator is root of sine square x minus sine square a dx. Now we separate and get two integral. There is we separate, then cos a is a constant and integral of sin x dx divided by this sine square. I write that 1 minus cos square x and negative this sine square is 1 minus cos square a, and minus here is second term is sine a is a constant and in integral there is cos x dx divided by this denominator is sine square x minus sine square a. Now there is cos a integral of sin x dx divided by, yes, this one cancel by this one and this term is positive and this one is negative. So there is cos square a minus cos square x, and next term is sine is constant and there is cos x dx divided by sine square x minus sine square A. Okay, then cos A, and let this integral as a I1 and minus sine A, and this one is I2. This is our equation number 1. The integral I is equal to cos A I1 minus sine A I2. Now we solve separately I1 and I2, another two integral. Then at first we solve the integral I1 this by the substitutions method, where cos x is t, then sin x dx is dt, and had formula that dt divided by cos square a minus t square. So I solve the integral I1. Here, and I1 is equal to integral of sin x dx divided by root of cos square a minus cos square x. Now let the cos x is equal to t, then negative sin x dx is dt, and there is negative, and dt divided by root of cos square a minus t square. Yes, cos square a is a constant, so the integral value of this term is cos inverse t divided by cos a, and value of t is equal to cos x, so the integral I1 is equal to cos inverse, and t value is cos x, and cos a is written at second. This is equation number 2. This is solution of the I1 integral, and the solution of the I2 integral. I2 is cos x divided by this term. So the I write here value of the I integral is cos A, and value of I1 is cos inverse and cos x and sec A. Yes, this is the, and minus sin A and integral I2. Okay, and there is equation number 3. Now we solve the integral I2, and I2 is equal to yes, the integral I2 is equal to cos x dx divided by root of sin square x minus sin square a. This is the I2. So there is we let the sin x as a t variable. Let the sin x is t, then the cos x dx is equal to dt. This term is the dt, and that is t square minus sin square a. This is a hyperbolic function, and right in a logarithmic function also. So the integral value of this term log of t plus root of t square minus sin square a. Yes, this is the value of equation number 4, and our by 3 and 4 we get the I integral is equal to So by 3 and 4, equation number 3 and 4, I integral is equal to cos of A, cos inverse cos x multiplied by sec A and minus this sin A is a coefficient and value of integral I2, and I2 is log of, and value of t is in this part value of t is sin x, so I write here sin x plus root of sin square x minus sin square a, and plus indefinite constant is c. So this miscellaneous trigonometrical integral is done, and now I will continue the miscellaneous and important trigonometrical integration for different board classes, and there is a CBSE, RBSE and other state board. This one is very important. So thank you for watching this video.